Stars are whispering tales of old, planets spinning, stories bold. Life is dancing through the night, countless worlds in the starlight. Galaxies full of mystery, infinite in their history. Beyond our dreams and our sights, life blooms in the cosmic lights, dancing on the edge of space. Take me away, feeling the universal grace. In the dark our hearts ignite, life across the endless night. Nebulas with colors bright, birth new wonders in the light. Comets trail their sparkling tears, life endures through the years. In the silence of the void, every heartbeat is enjoyed. From the depths and to the heights, life expands through cosmic night. Dancing on the edge of space, and off we go, feeling the universal grace. In the dark our hearts ignite, life across the endless night. Dancing on the edge of space, and off we go, feeling the universal grace. In the dark our hearts ignite, life across the endless night.
Hello there, everybody. Welcome. It is I, Mark Antonio. I am here, and it'll be just me tonight. Daryl, again, has a night off. He's actually feeling a little under the weather, so he will not be joining us tonight. But hopefully, there we go. We got our focus. Hopefully, he'll be better soon, and we'll be able to do this with him as well again. Let's see here. Alright, I'm just going to let it focus here. And I'm going to get my operations cam working here. It should work. Let's get it going. Alright, there we go. Okay. So tonight is going to be kind of fun. We're going to actually look at some northern objects and then wait for the winter Orion sky to come up and show you some new things that we haven't seen even the other night when we were doing this. I hope you guys are bundled up for those of you that are in the cold. We're actually having a blizzard outside right now here in Connecticut, and the blizzard is promising to go all night, and it's going to drop about 10 inches of snow on us tonight. Now in this view, you see a few stars. Now if I show you the targets about what's in here, well, now you'll see a few other things. And we're looking at the Flaming Star Nebula, which is here. Now there's actually a circle around this, and you can see it's outside here, so it's a huge nebula, and we're going to be looking at the central part of it. Those definitions for the size of the nebula, those really will do a little bit over the border. They don't really show you the actual extent. There's some software that does, but not this, okay? Yeah, and Carl Becker says it's 67 in southwestern Florida, and Richard Spencer is bundled up for the cold up in Canada. Nice to see you guys. I do want to say hello to the folks that are here. Michael Hedrick was number 1. Yeah, Michael, nice job. Renee Cruz is here with us. Nice to see you. And Carl, I mentioned, Daisy and Zoe are with us. Sam S. And you guys are the early birds, so we'll see who else is joining us. Jeff Penn is here tonight. Nice to see you, Jeff. I've seen you before, and it's nice to see you again. And we'll fill out, I'm sure, the attendance as we move forward. So, this is an area in the constellation Auriga. I'm going to show you where that is right now. So here is Auriga, all right? This is Auriga. Okay, and he's the goat herder, and this area right here is what we're looking at. It's called the Flaming Star Nebula, and the Flaming Star is actually a very interesting location. The only thing is, we don't necessarily get to see what it looks like when we look here. Okay, in here, it doesn't really tell us what it is. In other words, it doesn't show us the actual view, and it's a picture of it for sure, but it's not really the best picture. So what we're going to do is I'm going to take this as the star. That's actually the star. It's WAL 37. All right, and it's a magnitude 5.95 star. You can maybe see the star very carefully in a dark sky. You can see that star with your eyes. It's right about the limit. And so what we're going to do is we're going to actually look here. Let me get this. Let me get this in tune again here. All right, this is C31, Flaming Star Nebula, Bright Nebula. It's centered here. Okay, so let's go check it out, shall we? And once we get some of it, we'll do the annotation as well. It's nice to see everybody, as I said. So this particular nebula just needs about 25 seconds. You guys are going to be spoiled. By the way, in case I'll tell you why in a minute. In case you're wondering where the other telescope is and the setup and when we're going to have it and all that, I'm going to tell you right now. We are going to be, I'm going to be heading out to Arizona in just, a couple weeks. And we're going to install the new telescope in the building, hopefully. We still need more help from you guys. If you can see your way to help us with the donations, that would be fantastic. See, we're starting to see a little of the red of the nebula right now. So let's do this. Let's color correct it first. We're going to line up our curves under each other, and then we're going to do this. Watch this. Oh yeah, that's a little bright. Let's take this out. And now you'll see it. Look at that. Wow. So this is the Flaming Star, and you'll notice that why it's called the Flaming Star is because it looks like it's got flames rising off it. Right? Now, what we're doing is we're making a stack. That's what this is. I think you guys remember. We've talked about it many times, but just to let you know, telescope controls, telescope computer, the 2 telescope images in the building, some joker that thinks he knows astronomy down here in the lower left, and this right here, this this is our stacking window. It's in this window that we see each image come in, and we have stacked 3 so far. You can see over there, right there. It says 3. We got stacking. We're stacking 3 images. Now we're going to be stacking a 4th when we get to the end of this progress bar here. And this, with each stack, what's happening is we're making an image stack, an image sandwich. And each time we do that, all the random noise in the dark of space is mixed together and randomized out over a bunch of exposures. And this allows us to see more detail. Already you can see more detail coming in. This is our exposure over here, this field up there, and this is our gain. These 2 fields are very important, and the ones we're supposed to really depend on here. All right, and then this is basically an overclock. We can actually really push the processing. And then this is our focus section over here, thermal controls for the camera down here, etc. So that's how the screen works for you. This, of course, is the main view. Now, this right here, I'm going to do finer granularity by zooming in on it and bring it in. So now you see the curve. This white curve is the average of our red, green, and blue curves. And so the black level, I can bring this black level in closer to the top of the curve, and you'll notice how space gets blacker, but we don't lose any detail. If we cross over the top of the curve, we start losing detail because we're cutting off more and more of the nebula. Okay, now in a small telescope you might see something like this. In our scope you see something like this. It's really nice. Hey, Fantasy. So if you look at this one, this is our mid-level, that one out there, that's our mid-level. Let me move this over a little bit because it's out of focus. Okay, this mid-level bar over here helps us determine the mid-range values, and this is how I can actually bring in like this and really push to show you what's really hiding in the background. And here you can see there's a lot hiding in the background here. If we let it go where it wants, then it'll go to about here. This is the area where the noise is minimized for the moment. I'm going to actually increase its quality just like this. Watch, and boom, it immediately gets better. And then we have an enhancement. I'm going to put in a small amount of what's called unsharp masking, and we're going to sharpen up all these little filaments in here. As you can see, it's done really nice. Okay, so the Flaming Star Nebula, and I'm going to grab it again, and I'm going to make that our target name, by the way. All right. So, Flaming Star, this is a star, okay, right here, that's actually, let me just get a little closer to it here. Okay. This star here is the one that we're talking about right here. It's a special star, and it's, let me just center it and align it. Deep sky clock event. There we go. All right. So this particular star is partially responsible. I think, is it this one? I think it's that one. Yeah. But anyway, as you can see, the star in here is, what's going on is, this is all hydrogen gas in here. Hydrogen's simple. It's a proton with an electron, right? And if you have a star which is highly energetic, like this star, it will energize that hydrogen atom, and it'll energize the electron in particular and send the electron off the atom entirely. That's called ionization. You've heard about that in chemistry. Okay, so now you have a positive +1 charge on a proton and the -1 charge on the electron. Now the electron's floating around out there. Okay, so the electron's floating around, the proton's floating around, and this now means that the energy has been transferred from the star to the electron, and it's going throughout the nebula, and it makes the electrons in general jump off the hydrogen atoms. They're all ionized, and then they spontaneously bump into other things and fall back into another hydrogen atom, maybe very unlikely the same one, but maybe it's the same one, And when they fall into the atom, they give off energy, and that energy is in the form of light. And in the case of hydrogen, it's this red light that we see. Okay. Hey Bob, thank you so much. Very kind of you for joining us. Thank you for the super chat, man. That's Science Bob McGuire, fantastic guy. And when we look at the red glow, we also notice sometimes a blue glow. All right, and a blue glow as opposed to a teal glow. Remember, bluish green is teal and blue is blue. Okay, these glows here that we're seeing, these are blue. If we zoom in a little more, you can see that. Okay, so now you see there's also blue in here. What's going on there? Well, this star's giving off a lot of blue light, and that blue light has well, it's giving off red, orange, yellow, green, blue, indigo, and violet, the whole Roy G. Biv of the spectrum. But the blue light in particular is snapped up by the dust that's in this cloud. This is a dust cloud mixed in with all this hydrogen. This is all dust out here and hydrogen gas. If the hydrogen is near enough to the star, it can be ionized. You'll see a red glow around the star. Ooh, pretty cool. And also you have the dust clouds. And the dust cloud you see here is the dust cloud that's made from countless supernovae and dying stars, and these dying stars will release dust from their outer atmospheres, molecules of carbon and carbon mixed together, carbon molecules, silicon molecules that are made in deep space after a supernova. So the bottom line is this material ends up being brought back into the interstellar medium. But those but they show up as little particles of dust, micron-sized particles. Okay, these micron-sized particles are particles that beautifully love this blue light from the stars, and it will take it in and send it back out. It's called scattering. The frequency is just right that light can come in and bounce off and just reflect back out into space in all directions. I mentioned this the other night. The same process is the reason we have a blue sky. This blue that you see here is the same type of blue like in our blue sky, because the molecules in our atmosphere are doing the same thing to blue light from the sun as this dust cloud is doing to the blue light from this star. Cool. Neato. So, that's neat. I want to say hi to Sheldon, who just joined us again. Hey, Sheldon, what's going on? Nice to see you. And so, with this view of the Flaming Star Nebula, you can see that it goes way up there and over here, all the way around. It literally fills the whole field, you know? Now, let's just show you that thing you saw here was an artifact, because as I move it around, it's a redraw artifact with the graphics. It's not really something on the camera or whatever. But look how beautiful this is. We've captured 21 images here, and we'll go to 25. Yeah, we'll zoom in. Look at that. Wow. This is cool. There we are. So if you look, you can see there is an area here, right there, where we have a little... Oh, actually, I gotta show you. Okay, this area right here. Okay, you see that red? That red area right there is an area of higher density hydrogen. It's being ionized, and you can see it very much so. The higher the density, the more visible it'll be. Then on the backside, there's actually dust mixed in with this hydrogen, but there's so much hydrogen here, okay, in this location here, that it's actually making that visible like it's a spindle of some kind. All right. And then we see the dust shadow, not the shadow, but the actual dark dust that is not actually reflecting any of the starlight, like this dust is here and this dust is here. Okay, so we're actually seeing the anatomy of this beautiful nebula, and we're seeing exactly how it is reflecting the light and how it's actually ionizing the hydrogen. So we'll back out just a bit so you can see the entire nebula, the entire field of view. Look at that. I'll tell you one thing, when I first started doing the Flaming Star Nebula years ago, I looked at this and said, Flaming Star Nebula, not too exciting. And I would kind of avoid it sometimes. Then I realized there's so much going on here. Let's overprocess it and see what else is hiding. Look at all that. Now, if we leave that up, I can actually come in here and do this kind of thing. And you can see how much additional stuff is out there. It's really an amazing location. Now, I will say this, though. It's not a good location for planets and life because this entire region is really, really hot. There's a lot of ultraviolet radiation because that's what's needed to make the hydrogen atoms ionize. Okay? So we'll drop this here and go back to this here. All right? And then we'll back it up over here. Okay, and pull this in. There we are. So we're going to brighten this up to acceptable levels. And pull the darkness, pull the black level up. There we go. So that's gorgeous. Hey Tiffany, Tiffany's with us. So this is a beautiful nebula. Flaming Star Nebula. We'll save it in just a moment. First thing I'm going to do is take care of saving it with the annotations. Okay. So we saved it with annotations. That means that if you go to skytourlive.org, you scroll down to the selection that says take me to cool pictures, you can read how you can get at the photos and literally take down these photos that you're going to see that we're taking tonight and take them right away and enjoy them and look at them. And you can take a picture like this, or you can take the picture of the annotated one that shows you what's in it. It's really quite cool. Really quite cool. Very, very interesting. So, neat. Let's see. Sheldon said, enjoying the views. This is a wicked pic. Looks like velvet. Actually, thank you. That's a very good analogy, Sheldon. Well done. It does kind of look like a velvet cape or something that's lying, blowing in the wind or something, huh? That's incredible. Wow. Yeah, you're right. Very nice. So, hey, CND is with us. CND boy. All right. So yeah, so this is now up there. We have 31. I'll save one more time, and then this will be available to you up on the server. No one does this, there's no one doing what I'm doing. No one. I don't know why, and I don't actually know why I'm doing it. I know that I know I do it because I love astronomy and want to share it. But it was back several years ago when Bill Skywatcher and Keith Ickes, you might know Keith from P&K Space Imaging, they do the moon a lot, he and Paul, and Keith and Bill said, you gotta stream. I went, I don't even know what that means, man. So I watched a few of the streams and I saw, oh wow, that's kind of cool. Maybe that is something I should try. And so I bought black magic cards, I bought all kinds of hardware to do it. It is just something else. Yep. So I think that's pretty cool. Fantasy says this guy is doing exactly what you're doing. I don't even know who that is that you're talking about. Maybe so. But anyway, so we're actually doing some really cool stuff. I really like what we do. I love being able to showcase astronomy to everybody, and then give you the images that we take. I mean, that is the coolest thing. So, all All right, so let's move on to another object that I think might be good here. Hold on 1 second. Get rid of this. All right. So we'll save it one more time because I waited a few seconds and more images came in. The more images we take in, the better it gets. Norm Hughes says there are many people who go do live. Yeah, of course there are. There certainly are. I know I'm not the only one doing live astronomy, but SkyTour is something that I've never seen anyone do like we do. We take the pictures and we give them to you right away. We make them available to you like instantly as well. And plus we have our Patreon. We have our SkyTour shop on Etsy. Etsy stores right there. Okay, up on the upper right there. All right. So now let's say goodbye to this because we've already done this. Yeah, the color is beautiful. Color is gorgeous. All right. And now we're gonna go to our low light mode here, and this low light mode will allow us to see where we're going. I'll back out of this now. And we're going to go here to this right down below. It's called the letter Y cluster. But there's something else going on down here. And it's really cool. All right. So we're here. All right. Right. So now we're in a different location. We're actually very close to that same place we just were. All right. But now what we're going to do is we're going to check out this new interesting area because there's something cool going on here too. We're going to do a 25-second shot here and go into deep sky mode. All right. And this is the image of the last object we just looked at. And we'll leave it there. Michael Hedrick says, question, comment, C2024 G3 Atlas. Yeah, I really want to show you G3 Atlas, but it's best seen from the southern hemisphere. It's actually very, very close to our horizon, sets almost immediately, and so it's next to invisible for us. We can't even see it. Right at sunset, it's lost almost in the glare of the sun. It's not going to be above the horizon for long, unfortunately. So we can't see it, unfortunately. This is this cluster of stars in here, but this has a couple of interesting features that are right here. Now, they don't look too obvious right now because we don't have a lot of stacked images here. Once we get the stacked images, you'll see them. Okay, so we're going to color correct. There we go. Now in here, you'll see this excited hydrogen giving off, this is called hydrogen alpha. It's that same color like at the flaming star. And then we have this dust here that is reflecting back the light from the stars from this cluster, which are mostly hot blue stars. And so we see these are called reflection nebulae. More properly known as scattering nebulae. They scatter the blue light. And then you see these dark blobs of dust. These are light years across. So you could be inside that and not even know it. As a matter of fact, when you look at the Pleiades, you know that we've taken pictures of the Pleiades before. And the Pleiades have dust around them. We see the dust. It looks like a messy area of space. Well, the Pleiades weren't born there. They're passing through that dust. Okay? And it turns out that we, the Earth, the solar system, and the nearby stars to us, might also be embedded in this dust, and we just never knew it. So it's possible that we're seeing the universe through a shroud of dust. Isn't that cool? Genghis asks, curious if those darker areas, dust, are in the foreground. Yeah, those are up here, Genghis, if you look at my image, and the rest of the nebula is behind it. So in 3 dimensions, it would actually be in front of it, you know. And that's why it looks so dark and pronounced, because it's in silhouette against the stuff behind it. Okay, a lot of stars here in this region, so it's even hard to see. When we process, we actually remove the stars from the image and process only the nebula. Okay, now our exposure is 25 seconds and we're running at a gain of 250. That means that the sensor is 250, set to 250 out of 600, and that means the sensitivity, the higher that number goes, the more grainy the images look, and the more stacked images you gotta take to counteract all that grain and let it get dissolved into the background more, because it's random, right? So and that's 250 that we're running at now, and that's actually well more than good enough to show this very brightly. And we're doing a 25-second exposure. We could be doing 10-minute exposures, and yes, we'd see a lot more. But the problem with that is you don't want to sit for 10 minutes and just see nothing, you know, and I don't want to do that to you. So these two objects have a specific name, and let me see if they can give us that name. They probably can't. Yeah, they don't recognize the name here, but these are interesting. These are called the tadpoles because there's two interesting long pieces, strings of gas that are moving, going on the other side of this cluster. This hot young cluster is pushing dust and gas away in all directions, and it clears the space in the nebula from which it was within which it was born. And most clusters do that because of this. And so here we're seeing the remnant of this material. This stuff at the nose end here is very much more dense and isn't as easy to dislodge and blow away. So let's we'll save this with annotations right here. Okay, and when we save with annotations, what you get on the actual server is you get this image with the annotations. You get other things too that are in the same field. Okay, and then when we save it for real, you actually get the image. Okay, so without any of the annotations on it, so you get both if you want. Sheldon says, biggest tadpoles I've ever seen. Yeah, darn right. You're right. They are. Now, if we do this, it's gonna reduce the brightness of the stars a little bit, and we're gonna be able to see some more of the detail. And as we stack more, you'll see more detail in here. We have 12 we've stacked. I'm gonna back us off just a little bit off of our peak, and that's gonna help. Yeah, see that? Look at that. You're starting to see some detail in here. The tadpoles are very interesting. They're an interesting feature, and again, there's dark dust in here, and it's really this dark dust where it's at, because what that means is it's within that dark dust that life begins. I always say life was born in the dark, and it was true. It's in those dark dust clouds where you might have 30 atoms in a sugar cube size area. Once that stuff starts to collapse and you end up with 30,000, 300,000, and the atoms get smaller and smaller, or crunch closer and closer together, then you'll end up having objects formed in there like planets. And the hydrogen gas in there is going to get compressed as well through mutual gravitational attraction, and then you get stars that are born. And thus, around those stars, you might have a lot of this collapsing dust clouds, and they will form an accretion disk. A disk, it's a natural offshoot of collapsing matter. It will tend to go into a disk around a gravitational center, and you could end up getting this incredible set of planets around the star. It's how we started. It's what happened to us. So as I mentioned to you at the beginning, we are in the middle of a blizzard right now in New England and Connecticut. I'm in northwestern Connecticut, dark sky area, but the telescope here is 2,600 miles away out in the Sonoran Desert in Arizona, and we're running it there. We have an all-sky cam too. Let's take a look at that. Here's the all-sky cam view right now, and we're looking in Auriga, and if we turn on our constellations, you can see Capella up here, and you see Auriga, all right? And we're actually in the middle of Auriga right now. That's where we are. You'll see Orion is coming up. I'll turn this off so make it easier to see. You can see Orion rising here. Here is Betelgeuse. Here's Bellatrix. Here's Rigel. And here's Saiph. And here is Alnitak, Alnilam, and Mintaka, the 3 belt stars. And down below is the Orion Nebula and a whole host of tremendous things to see down here. This is Venus over here, by the way. Okay, and so we also have Jupiter right here. We have the Pleiades right here. These are the Hyades, that V-shaped formation you see in the sky with the red star prominently up there. That is Aldebaran. And it looks like it's either a plane or a satellite, a high-altitude plane or a satellite coming through in the next exposure. And this is a 12-second exposure, so that's a 12-second line. So the next one's going to be like here. Oh, it's going that way. Oh yeah, there it is. This is a plane for sure because it's got this staccato. That's the blinking lights. This looks like a satellite heading through. Another one here. Nope, sorry, that's Venus. That's a diffraction spike off of Venus. Yeah, that's a satellite coming through. And that's, like I said, a 12-second exposure, so it takes 12 seconds for it to go that far. And the camera's very sensitive, picks it up. It's probably going to put a hole in the Pleiades here. It's going to try to strike a hole. And it's starting to fade out now because it's crossing the Earth's terminator up there. That's what we're seeing there. Here's the winter Milky Way. This goes down to the summer Milky Way, which is off the screen now. But here it comes. There it is. All right. Yeah. And Orion's stars are so bright, okay, for a very particular reason. We're actually in the Orion spur of the galaxy. We're actually only 1,500 light years from Orion, effectively. These stars, Alnitak, Alnilam, and Mintaka, they're all roughly 1,500 light years. The Orion Nebula is 1,500 light years from us. Okay, and so we're kind of in the region of Orion. Right now, the Pleiades is a star cluster that's 400 light years away, so that's much closer than any of these stars. Okay, even Betelgeuse is about 750. The Pleiades stars are about 400. And so the Hyades cluster is a very, very close cluster to us. Aldebaran is closer and not part of the Hyades. Okay, Jupiter, of course, is in our solar system. And so that's pretty cool. Yeah, and then we have Gemini twins down here, and this is Mars down below Castor and Pollux. Gemini twins. Okay, there they are. All right, and so there's plenty to see. This is the whole winter sky coming up. This will eventually be dead center, and then we'll have a field day with all these wonderful things. So much to see down by Sirius, which is the dog star right here. Okay, so we got plenty to see, And as most of you know, I am an astronomer. That's what I went to school for. So when I look at the night sky, I just see opportunities to create life out there. I see all kinds of ways in which life can be formed. And these dark clouds are where it's at. That's why I tell you, life began in the dark. All right, so our tadpoles are developing well. Look at this. We can zoom in a little more. And you can see the head of this tadpole is very intricate with these 2 stars in it. and it trails behind. This one here, you can see it sort of snakes back. And again, the cluster in the middle here has this hot ultraviolet radiation that's pushing debris and gas out of the way. And this is one of the things that it's doing, is it's making it kind of erode a little bit. And thus, that's why it takes on the shape it does. Right? We see a lot of these radial streaky things moving away from very powerful clusters. And many times the stuff that's really dense won't erode away very quickly. And when it doesn't erode away very quickly, it protects what's behind it. And that's kind of what we're seeing here. So this material, right, any dust that's left here, it's sticking around because it's dense up here. And the erosion from these hot stars isn't affecting what's behind it as easily. And that makes a stalk or a pillar. In the summer sky, we have the Eagle Nebula with the Pillars of Creation. That's Messier 16, the 16th object in the Charles Messier's catalog in the 1700s. And so Messier created this catalog of objects that he didn't want you to confuse for being comets, because he was mostly a comet guy. And so those were just like junk objects to him. Still fascinating, but junk objects in a sense. So I thought it was kind of funny that people now spend a lot of their lives looking at all the Messier objects because they're so cool. But those are things that Messier said, avoid those, they're not comets. Turns out they're more interesting. Sometimes. And I promise you, when a comet is in view, we're going to look at it. G3 Atlas is not in view for us, right now. Hello to Kathy Messick and Stephen Jarrett. Hi, guys. Nice to see you. I think I saw Mr. Richards with us. Hey, how you doing? Nice to see you. Dagger's with us. Daggerspell, nice to see you as well. Yeah. As I said before, Daryl won't be joining us. He's under the weather tonight. I'm in the weather. He's under the weather, which is kind of interesting. I'm in the weather. Hopefully we don't lose power. If we lose power, then we'll be kind of stuck. In an emergency, I can go in my phone and connect to the observatory and shut everything down, but I'd rather not do that. And again, as a reminder, next month, on the 4th of February, I'll be in Arizona. And somewhere around the 6th, we're going to be installing, if we can, the second new telescope. Hopefully, we can get some more donations to allow us to do that. We have to pay for the pier to be made, and the installation of the pier and everything. I'm going to be doing most of the work along with Marianne and Tara to set up the telescope on that pier. It's going to be a very tall pier because it's going to be near the roof of the building, and the building we want to use is a roll-off roof observatory, and we're going to rehab it and get it ready for us. Again, everything costs money, you know how it is. But anyway, Lynn Beats is with us. That's Kyle. How you doing? He says he wants to look at M106. He says it's up. All right, well, we'll check it out maybe. So here you see, this is the Y cluster. It's also known as the cluster that has the tadpoles in it. We'll zoom in on these a little more, just for a moment. Let's go right in there. Let's get right on down and dirty with these guys. Yeah. So you can see the tadpoles now streaming away back there. Let's see if I can grab any more detail in here. Let's see if we can harness a tiny bit more. Oh yeah, look at that. Pull something out. Oh yeah. That's good. Yeah. So yeah, so the tadpoles is a very interesting location for the reasons I mentioned. And this shows a little better the intricacy going on back there. Yeah, that's neat. Okay, we'll bring this back. Alright, so when I save these, it saves in an astronomical file format called FITS, FITS, and basically that looks like a black image with a couple of dots for some stars, and you could process them and pull out more detail. But also I save it just as you see it here. So that image that you're going to see right here, that is immediately being sent up to our server as we speak. That's our server. Let's go into our server, and you will be able to download this, and do what you want with it. Turn it into collector cards, Or you can go to the Etsy store up here at our Etsy store, SkyTour shop, and you could buy mugs and so forth with all kinds of things, like the flaming stars on some of our mugs and everything. It's really pretty. You can request an object on a mug, and I can make them special and have them available to you as well. So you can get anything you want. And Marianne Robb is here, one third of the happy triumvirate that makes up SkyTour Livestream. And Michael Hedrick has a random question. He's never random, guys, just so you know. He's never random. Is there a book or chart that tells you where you can go on Earth to see the same sky in the winter as you would normally see in the summer? Okay, Mike, I want you to think that through. Okay, what makes our winter sky versus our summer sky? Okay. Our winter sky is dependent on where the sun is. When the sun is on the opposite side from our perspective, we see the winter sky. All right? As we go around the sun, what's happening is the constellations that we're used to seeing are going to end up getting lost in the sun for a period of time and will be in our daytime sky. All right? Like right now, winter constellations like Sagittarius and so forth are in the daytime sky. And so we can't go anywhere to possibly see that except get off the Earth, block out the sun, and look towards Sagittarius, and we would be able to see it. But because we have blue sky from that scattering process, that same thing that makes these things blue, okay, we can't see the stars that are out there. If we had no atmosphere, we'd be able to. But then again, we'd be dead because we wouldn't have an atmosphere to breathe. So you can't actually see the winter constellations until they pull out from behind the sun. And it happens every year. Okay, so let's see what's going on here. And we have Timmy Lee Despain. How you doing, man? Nice to see you again. He was in here last time too. Yeah. Heading out, stealth engaged. All right, brother. See you later. Thanks for coming. Okay. All right, so that said, Michael, hopefully that answers your question. There is no place you can go to see the winter sky in the summer because it is by the sun. It's in the daytime sky. That's like when they say, oh, okay, where's the sun right now? Well, the sun is in, and they give you a constellation, right? They give you a constellation. Oh, it's in Libra. Okay. That means that the stars of Libra would be seen if you could block out the sun because it's in Libra. We see it as the Earth's going around the sun, but the stars that are behind the sun are the ones that become our zodiac constellations. So the sun can be in Sagittarius. The sun can be in Capricorn. The sun can be in Gemini, okay, at different times of the year. And so we see an ecliptic path drawn in the sky. In fact, let me go here and back out for you just a minute. This might be a very good thing to try. Oh, how do I get the ecliptic lines? I want to show you. An equinox is not that. No, ecliptic. Here we go. Ecliptic grid. All right. Let's try that. Let's see if that does it. I don't see the ecliptic grid. Well, if you want to know where it is, you just have to draw a line between Venus and Jupiter and Mars. Okay, and that is the line of the ecliptic. That's where that's exactly where the plane of the solar system is. Okay. Oh wait, I think this is it. Let's try this. Let's see, hold on. That might do it. There it is. Okay, so here's the path that the planets run. This is the plane of our solar system. Now, if we go directly to the south, you'll notice that it's on a weird angle. Why is it on a weird angle? Because we're on a weird angle. Or remember, our Earth is tilted on its axis. So that's the ecliptic. Notice Jupiter is going through the ecliptic. Okay? This is also where the sun goes through the course of the year. So when we zoom in here, we can see that the sun will be here, okay, at one point. Okay? The sun will be out here at one point. The sun will be here tomorrow. You know, that kind of thing. So over time, during the course of the year, the sun will be in different locations relative to our Earth, and we'll see it. See, Venus is on the ecliptic too, plane of the solar system. So is the sun. If we back out and I get rid of the ground, you can see the sun down here on the ecliptic as well. And right now, if we zoom in on that, okay, we can see that the sun is kind of near Capricorn, right? Which is really interesting. And that's kind of neat because this sort of shows you identically what we're talking about. It shows you how it actually works, right? So if we click on the sun right there, all right, we see where we see right now that okay, the sun is Mercury's right here again on the ecliptic again. You'll notice that here's the summer Milky Way. Well, the sun has made it past the summer Milky Way, right? And it's heading toward Capricorn, all right? So if we put the ground back, you'll see that, well, it's below the horizon, right? So as we go around the sun, we see different stars in the sky because the sun appears to be in front of those stars now and then. So there we go. I know that that's not as good an explanation as you might want. Now let's go over back now to a place where we never have to worry about the sun going through, and that is the constellation of Auriga. All right, so let's go over here. Let's back out. All right, there we go. Okay. All right, so we did the Flaming Star Nebula. Now we're doing the letter Y cluster. And the next one we're going to do is this crazy guy down here. And we'll capture both of them at the same time. All right. So we'll just center on that right now. Okay, we've got quite a lot we've done here, but we'll need them for getting the data out. So we're going to save. And I'm going to first set the target name here. NGC 1893. Yes, cluster. Set the target name. All right. Yes. Okay. And now we'll save it. It'll go to the right location. Save exactly as seen. All right. So there we go. So this image is now out there and can be acquired by you at any time through skytourlive.org. All right, let's go to our low light mode again. And we're going to go to the Spider Nebula and the Fly, the Spider and the Fly Nebula. Right nearby, actually. And we're going to go right now. It'll be just a little jog over from here. And you'll see the telescope moving, very little. And now we're in the region of the Spider, the Fly. Let's fit the width. Alright, and now there we go. Let's do this first. Alright. That's the region we want right there. So we're going to drop down to it. Alrighty. Alright, and now once we do this, I'm going to stop here. We have a star cluster and nebula over here. And we have this guy right here. So we'll just drop it a little bit lower. Alright. And then we'll be able to take a good shot of this. I'm not a fan of the big snowstorm going on outside right now. 25 seconds. We'll try this. We're going to go to our low light mode and go get our stack. Nicey nice. As I mentioned, Daryl is under the weather tonight and won't be joining us. Alright, so this is the Spider Nebula and the Fly Nebula. Now, Spider and the Fly sounds interesting. Jessica S., how are you? Nice to see you. Alright, now let's pull this. Let's pull our black level to the left of the curve a little to help get more data out of it. And then pull this one middle range in. There we go. Spider and the Fly. I'll just name it this because it's not in our database. Izabela said she would be here tonight, but I think maybe she may have slept through it. I don't see her anywhere. That's okay. Kyle asked for the question mark nebula. I'm not sure. You did ask for Messier 106, I believe. Let's go see where it's located. Yeah, if you notice, it's not up yet. It's way down below the horizon here. Kind of thought so. Alright. So we're not there yet. Alright, so now we are up in Auriga here, right there. Looking at the Spider and the Fly Nebula. Okay. Let's see where this is. Let's see where the sender is. Okay, right near the spider. Okay, that's good. We'll just center on that. Excellent. Alright, we come back here. And let's go through our different reticles. That last one we're going to go through a lot more together. I'll show you more how that works. Not tonight though. Now by now you know what the red means. The red is a hydrogen emission region. Alicia is with us. Hi Alicia. Roller Derby Queen. Simon Thompson over in Perth, Australia. Hey there, Simon. Nice to see you again. How is it down there? It's summertime for you all. Which is something that flat earth idiots can't fathom. Is seasons. They don't get it. Izabela is here. Look at that. Hi, Izabela. That was fun. I actually just talked about you, Izabela. I said, yeah, you threatened you would be here, but I think you fell asleep. That's all right. Oh, this is wild. For the first time, I noticed something odd here. This looks like two eyes, a large gaping mouth, and this creature going, ah, with a big mouth. That's pretty cool. Interesting, huh? Neat. Rockstar is with us. Hey, Rockstar. Nice to see you, man. Okay, we're going to just do a 12 shot here. Then we're going to take off to another object I want to really see. Things you'll like, I know. Okay. Save exactly as seen. Alright. So this will be up on the server at skytourlive.org. You can go there and check it out and enjoy it. Alright, and now go to our low light mode, and we're gonna look for, because it's right near us, it's right nearby, not far. We're going to a nebula called the California Nebula. You'll see our crosshair show up here. It'll be showing up here in just a minute. There it comes. Zip. There we go. And so what we have in here is the California Nebula. You can see a little bit of the filamentary structure here of it, and I want to see if I can pull it over more and show you more of it. Alright, we'll come up here. You can see faint red in here. This is an extensive nebula that is powered, so to speak, by a star down. It'll be down here. It'll be coming up. Let's do a quick 10-second shot just to see where it is relative to us here. So I would do that and do this. Yeah, it shows that's right in the center here, so I thought it was, but let's just catch it. Yeah, there we go. Okay, this will be fine. Yeah, this is beautiful. So we'll go into our stack now. And the live stack that we're going to look at is going to clear itself. And we're going to go do a 20-second shot. We don't need to do 25. 20 seconds is more than enough for this. Okay. So we'll clear it. California Nebula is beautiful, and I will show you a little bit more about that. Okay, the California Nebula is powered by a star called Menkib down here. Menkib is to the lower right of our image, but look at this. Menkib is down here. It's just out of the shot down here. And Menkib has caused this curve in this nebula in all likelihood because it's pushing it away because it's a very, very hot, powerful star. If we go look at Menkib, it's light years from this, but it's more than close enough. Okay, this star is a type O. It's an O type O star, 07.5. It goes from 00 to 09, so it's a very powerful 07 star. And as an 07 star, okay, in fact Menkib is just out of shot. As an 07 star, it gives off most of its energy in the ultraviolet, all right? And so any hydrogen nearby will be ionized. And you can see right here, this round little thing right here, this is the halo from our very fast light capturing system of Menkib itself down here. So it's just out of the view, but that's okay. I don't mind. Hey Goblin, how's it going, man? So the hotter stars are the O-type stars, right? As we have always said, we have O, B, A, F, G, K, and M. Okay, O and B stars typically occur together in the galaxy in associations known as OB associations, because those are the hottest, youngest stars. The Pleiades are all B stars, for instance. The main Pleiades are B stars. Yeah. Yeah. Oh, someone's talking about Beatriz Villarol, probably. I know Beatrice. I've talked to B. Yeah. She's a cool lady. She has she's an astrophysicist. Astronomers and astrophysicists get along very well, you know. We certainly respect each other's work, that's for sure. Kyle says, what's the longest exposure you've taken without inducing star trails? That certainly depends on what you're using for a focal length system. Our system here is a focal length of 520 millimeters. So if we take a photograph that's, say, 3 seconds long, we're going to get trails because we're zooming in a little bit. However, with a 50 millimeter lens on a camera on the tripod, you can leave it open for about 20 seconds and not get any trails because the relative motion is far less. Look at this beautiful, expansive nebula. Isn't that pretty? This camera that we're using, as I said, this is a new camera to us. Actually, why don't we do this? Why don't we get rid of this right here for now, and let me dump this down and give you a full view. That's nice. I mean, some people say, "Oh, it looks like a dragon," you know, with its mouth open, breathing fire. Yeah, pretty cool. Well, you mentioned how long can you leave the shutter open, Kyle, without inducing star trails. I assume you meant without tracking. With tracking, I've done 10-minute exposures with this, and I can do an hour or 2 hours. It doesn't matter when you have a tracker that's accurate. We have a sub-pixel tracker on here that actually corrects for all of the errors. And if we come up and look, we're using a filter, what's called a full width half maximum filter. Here it is, and you can see these numbers. These are the values that are being used to determine whether the stars are going to be round or whether the stars are going to be elongated from trailing, from the fact that it's not guiding right. And then that can be induced by wind, causing the telescope to move. If you look at the telescope, when you saw the telescope before, let me just bring it back momentarily. Okay, the telescope has this big barrel on it. That's like a giant weather vane, and so it can capture the wind, and we don't want that. It'll go away now. All right, so we don't want that at all. We want to be able to have this thing just be beautiful and show us this gorgeous stars without any trailing. So the full width half maximum filter makes sure that the stars stay a certain diameter, and it'll be a red bar and not be captured in the stack if it goes above that. Okay. All right, Michael. We may or may not be streaming, Michael. We got it's gonna be an early night tonight, but we'll be able to show you more stuff, moving forward, without a doubt. So, you have a good night then. If we don't see you back, Hein Sherry's with us. Hello, Hein. I have not used the LCO data. That's Las Cumbres Observatory data. That might be cool. I got to get into that a little bit more, Kyle. All right, look at that. That's pretty. Okay, let's do this. We're gonna dock this up again, and we'll bring back the telescope. Just push that over and bring the telescope back. Thank you. Okay. All right. Oh, that's pretty. All right. So what we'll do now is set that target as a target name. All right, and then we'll save it. Save it exactly as seen. Very nice. All right, now we'll go back to our low light camera to find the next object. Okay, let's see here. We'll come out now. Oh, let me just save the last one. There we go. Every last frame helps when it comes to getting rid of noise. You can see this beautiful little tiny dark nebula inside this hydrogen emission area. Really cool. Alright. Now down here. And get to our low light mode. There we are. And now let's fit the width. Let's actually zoom to that. Okay, now if we come down, back out of here, this next one is going to be interesting. Alright, I'll tell you why. Because this one is what's called the Perseus cloud. It's a cloud of dust in Perseus, which is just stunning. It's really beautiful. And I'd like to try and capture that tonight. Alright, here we go. Let's center you up. Get rid of this. Get rid of that. Alright, yeah, what's this? Okay. Alright, so the Perseus cloud here, you'll notice that you don't see a whole lot of stars, but there's a lot of Milky Way here. So what's going on? What's going on is there's a lot of dark nebula here that's blocking your view of the stars. And we're going to just take us a little bit west here. Like this. I just think it's cool that I'm moving a telescope 2,600 miles away right now. Alright, and we'll move up a little bit. David Galish, how are you? SkyTour Live fan, alright, man. Been wondering where you were. You're more than welcome, David Galich. I'm glad that you enjoy it. Okay, there's all dark nebula in here, so let's try and find it. We're going to come up here. You can almost see how it's defined by the stars, the lack of ability to see the stars. There's a nebula right here which will show up, but there's more down here. I'm going to try and capture that. We're going to go 25 seconds here. And I'm going to up us up to 300 on the gain here. And away we go. Off into low light mode. Low light land. Alright. Yeah, I heard there was a football game on. So this is a pre-inauguration, I guess, a pre-inauguration stream, isn't it? For those of us here in the U.S. I think we're inaugurating a new president tomorrow. Okay, so you'll see this nebula here. It's a blue nebula called Reflection Nebula. We haven't even balanced our colors yet. I'll do that first. Okay, so that's going to get our curves aligned. There they go. And then we'll now align our different curve values. There we go. Alright, so let me move over now. Alright, like that. Let's move our black level up to just shy of the curve. You can already see the cloud here. You see that? There's a lot of cloud here. Space is filthy, guys. It's filthy dirty. It's full of dirt. It's full of dust. It's full of, not dirt for real, but it's full of dark dust and everything that's, you know, to us, when we think of dust, we think of stuff we want to sweep off of all the things that are, you know, like our lampshades and things. But to astronomers like us, well, what we look at dust is we look at that as the crucible of life. You know, the most amazing locations from whence life springs. And you'll notice that, like right here, this little area right here, it's really interesting because you look here and you see there's two stars in here, and you see a subtle glow around them. And that subtle glow is part of the dust cloud and part of the hydrogen gas that's being ionized in there and glowing softly, called a diffuse nebula, diffuse glow. And then over here you see some subtle black lines, and these subtle black lines are more dust coming down into the field, into the view. And this is all dust in here. all dust. You know, nobody. I mean, they didn't have a feather duster, a cosmic feather duster for this region. You know, and if you want to see what's really here, what we do is we can overpower. We can do an over processing right here, just to kick it up a notch, so you can see. Now you can see. You see a reflection every here. You see all this dust here, okay? A bright star there. That halo is due to our optical system. Okay. But then we come back down because that's too bright. Ah, Daisy and Zoe. That's a really good point. A stellar chimney sweep. That's right. That's really cool. We need a stellar chimney sweep. You're right. Now sometimes you can see the dust better when you make the image smaller. And indeed, now you can kind of see it, right? And we can highlight it a little bit by pulling this in, make it a little bit too bright. But you can see the dust streaks in here coming in. It's really an incredible location. SkyTour Life Fan has a question. If you take all the dust from inside an average sized family home, you make a dust ball the size of a small to medium rock? Actually, you know what? That's a really good analogy, and I'll tell you why. If you take all the dust from in your home and you compress it as small as it can get, squish it together within reason, you're probably not going to make something more than the size of your thumbnail. Okay? Now, some people are out there saying, oh, you haven't seen my house with all the dust. And that's true. You probably got lots and lots of dust. But it compacts down really small. So imagine then, to make a whole planet, you need tons, I mean, trillions upon trillions upon trillions of tons of this dust. And most of this dust is in an area, we measure the amount of dust in a cubic sugar cube size to about 30 atoms. And in a regular sample of air, that's the size of a sugar cube, there's like 10 to the 19th, 10 to the 20th atoms in there. Okay? But 30 atoms in one of these typical interstellar dust clouds, and it could get as high as 30,000 atoms in a dense cloud. But then when they start doing gravitational collapse, well, then all bets are off. Then they collapse and they end up becoming quite big. Cosmic Ray says, did you see the video of the meteor strike? Yeah, for the first time in history, we captured a meteor hitting the ground on a Ring camera. Not we, but somebody. And I thought that was pretty cool. You actually saw it, you heard it hit. It goes, psh, and it came in. If that hit you on the head, it would hurt pretty bad. But you know what? I'll tell you this: it fell at the terminal velocity. It didn't fall at thousands of miles an hour. Okay, because when it entered the atmosphere slowed it down. Most of it burned away, and then it started to fall on a trajectory of a falling trajectory. So a rock it probably hit the ground at the same speed that dropping it off the Empire State Building would cause it to do, because it was that's how far you need to drop it roughly for it to reach its terminal velocity. Pretty cool. All right, let's see if it knows the Perseus Cloud. Well, it knows that anyway. It knows the Perseus Cloud. Good. It says the Perseus Cloud is this, but it's really not. It's all this down here. There's so much more to it. Okay. I'm noticing also that our full width half maximum has been off, so I won't waste any more time on this. I could have just raised it up this high and captured so much more, so much quicker. My mistake. See, now it's starting to come in. I'll give it a few more. Rockstar. I miss my dog too, man. Yeah. SkyTour Live says, I believe that's like the myth of dropping a penny off the Empire State Building. Yeah, a penny dropped off the Empire State Building, it'll hurt, but it won't kill you. Depending on the size of the rock, though, well, higher mass, if it's made of iron, it could end up with a terminal velocity that's not as affected by the air, so it can get a little higher, Izabela says, how is Dingo? Oh, Izabela, Dingo passed away. My little Australian herding dog there. Yeah, she was a good dog, that one. Really liked it. Yeah. But you know what? I'm still thinking of Dingo. Every time I eat pizza, I get down to the crust and I throw the crust on the floor. There's still crust on the floor, and there's no dog coming to get it. I'm kidding, of course. Indy was the first to go. She was a black lab shepherd pit bull mix. And that made a dog that was so dumb it didn't know how strong its bite was. Let me tell you. And she was great. Big galoot. She went next door to our friend Mike's house. Has the house next door, and he was relaxing on the couch, drinking a beer, and he had a screen door on his deck. Well, Indy climbed up on the deck and went over and says, "Hey, it's Mike," and she just walked right through the door. Right, okay, it's like 9 o'clock at night. She walked right through the door, slammed, knocked the door off the hinges. Mike panics, thinking a bear is coming through because she is black as night. Okay, and she comes in to go. It's like, oh God, it's a bear. It was very, very funny. Of course, it was also funny while I was making sure I paid for his door, but it was really funny. She was 118 pounds, didn't know her own strength or how hard she could bite. Dingo, on the other hand, she was a very powerful dog. She was one of these Australian cattle dogs, and she was too smart for her own good. She would wait for me to leave the room and then sneak up on the table. I know other dogs do that, but Dingo had a special way about it. She would sneak up on the table by very carefully moving her paws and just gently pulling herself up, not jumping, okay? And because she knew that'd be stealthy. Oh yeah, she got a whole pizza that way once. Yeah, but you know what? In the end, the dogs aren't smart enough to know I better pick up the box on the floor and put it back on the table. See, yeah, now that we're capturing these images, check it out. You can see these beautiful clouds coming in here. We'll zoom in a little now. And this is all diffuse clouds of dust over here as well. This is beautiful. All right, let's pull some details out of this. Let's see how much more is hiding. We're going to overprocess for a moment. Yeah, look at that. There's all kinds of stuff in here that's hiding. That alarm you keep hearing is my alarm to go up and put a log on the fire. And I've ignored it for an hour, so I may have to relight the stove. That's okay. Alice Pooper, welcome, My Leone, how are you? And mine's a little Rasputin dog. Very good. So let's see. Dingo was a legend, yeah. Alice Pooper says, when a star dies, the planets around it lasts forever. Actually, a really good point. Okay, I used to teach a class in astronomy called What Happens When the Sun Goes Out. And it was targeted at all ages because you know, when you get to adults, you can just spend a little more time with some physics. Okay. But the bottom line is the planets would continue to orbit the remains of the sun. But you have to understand that a lot of the mass of the sun is going to be expelled as a nebula around the core, the remaining core. Our sun will become a white dwarf, and it'll become a stellar corpse that's just a white dwarf. And the white dwarf will not be as massive as the sun was, okay, because some of that mass is expelled out into space as a planetary nebula. Now that will be very hot. The sun will have grown into a red giant before it actually shrinks to a white dwarf, and when it goes to red giant, it will certainly eat Mercury up, most likely take Venus with it, and maybe engulf the Earth, destroying it too. But once it gets down to the white dwarf stage, Mars, Jupiter, Saturn, Uranus, Neptune, and Pluto will continue to orbit the remains of the sun. However, it will be modified. It'll be a modified set of orbits because there won't be as much mass. So the solar system will go through a redistribution, you know, a time where it's going to redistribute the orbits a little bit, because if the sun gets less massive, the planets can go a little further out, and so they might end up in some elliptical orbits, and that could lead to some chaos before it maybe settles into a final state of some type of equilibrium, which is kind of interesting, you know. All right, let's do this. Pull this out a little bit. There we go. Look at that. Look at all the cloud in here. Isn't that something? See the subtle detail in here? This is called the Perseus cloud, and I wanted this in there too because that cluster is what's talked about primarily as the Perseus cloud. See, it's the Perseus cloud, but there's a molecular cloud associated with that reflection nebula, and that is exactly what we're looking at here. I'm going to save this image with annotations anyway. Alright. Okay, so this is the image that's up on our server right now. So you get that, and you'll see all this. Okay. Alright, and now we have 21 shots. We'll save it. And we'll do save exactly as seen. I'm really pushing our luck because with the wind howling out there and with the weather out there, we could lose power, and then the building will stay open until I can shut it. So I'm tempted to make this the last object so that we can end while we still have power and while I can still shut down. So I may just do that because I'm kind of getting a little nervous, you know. Michael Hedrick, log in the fire, log in the fire, don't worry, I'll entertain him. Thanks, brother, it's okay. Alright, got 23 shots. We'll just save that, save exactly as seen. Okay, that's good. Alright, well, I think I'm gonna end up calling it right now because I've had the lights flicker a couple times and I don't want to lose connection to the observatory, so I will have to shut us down for now. Like I said, we're in the middle of a big storm here, but I hope you guys enjoy your night and have a good time, and I will certainly be talking to you again because we want to do this again very soon. Alright, so you have a good night, and we'll see you later. Sorry for the quick ending, but we gotta go because we're gonna run out of power here. We're gonna lose power. Alright guys, see you later. I'm gonna go hide now. Bye.
Stars so bright in the sky, on Arizona nights they fly. circulating colors rare, galaxies beyond compare. Sky tour in the night so clear, brings the universe near. Real-time wonders to see, streaming light for you and me. Lift your eyes to the skies, universe in all its light. Sky tours bringing the views. Every night feels brand new. In the dark, the night unfolds, stories of the cosmos told. Through the lens, a distant dream, living real like a gleam. Far away, up so high, across the stars beyond the skull. Through the lens, a distant dream, living real like a gleam. Lift your eye up so high, across the stars beyond the sky. Sky tour shows us the way, every night a new display. Lift your eyes to the skies, universe in all its light. Sky tours bringing the views. Every night feels brand new. Lift your eyes to the skies, universe in all its light. Sky tours bringing the view.